Sorry about that. So we're going to continue on with this question. And we started with the rectangles, and we determined that their distance or their length was 1. Then we got our 4 rectangles, and their x values are actually going to be x1 equals 1, x2 equals 2, x3 equals 3, x4 equals 4, because that's the right endpoints. There is the formula that you can use, which I highly encourage you become practiced with. But in this case, we can just from our picture pick out those points. And then remember that our R4, which is our Riemann approximation of the sum, is f of x1 times x1 plus f of x2 delta x2 plus f of x3 delta x plus f of x4 delta x4
Final call for the doors, final call.
delta x,
Doors are not closing, stand clear.
which is equal to f of 1 times 1 plus f of 2 times 2 times 1 plus f of 3 times 1 plus f of 4 times 1. And in this case, we get, because it's the square root function, this equals root 1 plus root 2 plus root 3 plus root 4, which equals 5 plus root 2 plus root 3, or sorry, not 5.
Our next stop is Brampton Innovation
This is
District.
2, this is 1, so 3 plus 2, root 2 plus root 3. And that's our end approximation. So now we're going to look at this integral. Now, when solving this integral requires us to do a u substitution. And the reason why it's a u substitution is because we want to expand that x squared into this square root, but we can't do that. So we're going to take the issues with the square root, and we're going to move those multiple terms from being inside the square root to outside the square root. And we do this by letting u equal 2 plus x. So du by dx equals 1. This gives us the integral of x squared root 2 plus x du by dx. But here, this tells us that u minus 2 equals x. So we get the integral of u minus 2 squared times u to the 1/2 du by dx, which now what we can do is we can expand the numerator or expand our square to give us u squared minus 4u plus 4 times u to the 1/2 du by dx. Expanding this in gives us u to the 5 halves minus 4 u to the 3 halves plus 4 u to the 1/2 du by dx, or the integral with respect to u and then converting back to x land. And this gives us u to the 7 halves over 7 halves minus 4 u to the 5 halves over 5 halves plus 4 u to the 3 halves over 3 halves plus c. And last but not least, we need to take our u to convert it back. So this is x plus 2 over 7 times x plus 2 to the 7 over 2 minus 8 over 5 x plus 2 to 5 over 2 plus 8 over 3 u to the, or x plus 2 to the 3 over 2 plus, and thus we have our solution after we substitute back in to x. resume play. So now we've switched over to the quiz, the mock quiz, and we're looking at A5. And in here, we're given a barrel that has a water leaking at a certain rate. And it leaks at this rate since it first started to leak. And we want to know how much volume of water is lost between 2 minutes and 5 minutes. And if you remember from our class, we told you that given we know what the rate is, we can't figure out the amount of volume left at a particular time. But over a given time, we can use that rate to determine the total volume lost. So from here, if we're looking at the amount of volume lost given a change of time from 2 to 5 of our equation, and now we put our rate equation inside with respect to t. And now this is the change in volume with respect to time. That's our rate equation. And here we're given a rate equation. So this is equal to 2 to 5 of 4 plus t with respect to t. Or 4t plus t squared over 2 evaluated from xt equaling 2 to 5. And if we plug this in, we get 4 times 5 plus 5 squared over 2 minus 4 times 2 plus 2 squared over 2. This here is equal to 10. So it equals 20 plus 25 over 2 minus 10, which equals 10 plus 25 over 2, or 20 over 2 plus 25 over 2, which equals 45 over 2. And we have our